This is Lost in Electronics. Today our video is going to be about is how much bandwidth do we really need to be able to use? Because of the fact a lot of times we may be having these high-speed internet connections, even though you say, okay, I have a gig connection or a 400 meg connection or 100 meg connection. Do I really need that additional bandwidth? Because a lot of times I know within this economy that sometimes every dollar counts, and you want to make sure you're not overpaying, but you want to make sure that you get the proper speeds based off what you use. It's nothing like being in the middle of your kid's school, and then you start seeing in the middle where you can't see his teacher, or in the middle of being in the middle of your work, and you're in the middle of your VPN just drops. So we want to make sure the biggest thing is looking through what bandwidth you're using. So I just went through and did some basic things on what an average person would use. How much bandwidth are you going to use? What are you doing? For example, I was just seeing an average house, most people have about 4 TVs. Let's say, example, they're running 4K TVs. So based off of what we're using here, let's say everyone watches probably Netflix, Amazon, or Disney Plus, or something close. So we're going to go ahead and say we all have 4K Ultra HD, HD 4K televisions. So we're going to go ahead and go 25 times 4. There is your 100 meg connection using. So those things. But on average, most people probably store using 1080p TVs. So in that kind of case, we'd want to go into look at 5 megs apiece for each of your streams, multiplied by 4. That's going to be 20 megs apiece. So again, you would still have, if you had a 100 meg connection, you would still have approximately about 80 meg to use. The same thing here for your Xbox. It only uses about, per stream, you approximately use about 15 or 20. Minimally, 3 megs you could technically run to, but if you want to get a pretty good lobby and you have multiple people in that lobby, you're looking at about 15 to 20 megs per user on average. So again, those are things that we'd always want to take a look at. A lot of times it's just looking at kind of what options we have out there. So they do have it. You just have to look at whoever your internet service provider is and what there. Sometimes it depends on what your family needs are. Again, it depends on how many smart home devices. Each of those smart home devices do use bandwidth. On average, you're probably looking at about half a meg per connection if you're looking, depending on what you're trying to do. If you have something like door sensor, you're probably gonna not even use that much. But we're just going to use from there. Now, your cameras may use a little bit more, but you'd have to look up on the site on the minimum bandwidth requirements for your stream. So again, we can use the example of what an average network uses. I'll go ahead and pull my connection here, so we can show an example of what I'd be using here. This is like one of the other videos of how we were talking about how we were going through and showing those things. In this kind of case, we're going to go ahead and do an endpoint scan. Here shows all the devices I have currently connected here. So we got, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And again, we'll go ahead and say basically 21, because we're actually 22, because we don't really need to counter switch, because we're not having anything really at this point. The switch is not going to use itself that much bandwidth. So we're going to go ahead and here, so we're going to go ahead and we can see how many these are like little Raspberry Pis, and let's say here. So let's say example, if we're looking at this basically per device here. So we're going to go ahead and clear everything out here. So we're looking at approximately 20 devices. Let's say they're using 5 meg apiece. Then that's about 100 megs. So most likely you're probably going to, on average, let's go ahead and say we have, we're going to go ahead and let's say that we're having, and that just shows you a perspective of you may not always need that much, but it depends on everyone you're using. And also depends on what type of router. Each router is going to be able to handle different requirements. Again, you want to look at there's more than just, hey, do I need the bandwidth? Because this is the next topic we want to look at. Is it because of the equipment we're using, or is it because of the bandwidth we have there? Even though I have that many devices, my router's only putting 14% of the usage out here. So let's go ahead and look at a real time what we're using here with all these devices right now. Granted, there's not much people on my network, but to put it in perspective, I have a 400 meg connection. I'm barely using any of the bandwidth on my connection. My provider's doing a pretty good connection, providing the connection they promised me here. So at this point here, the maximum this could ever pull is about approximately about 500 megs, but on average, just because most companies gear you up a little bit, but again, it's going to, I have a 400 meg package and I'm barely using the service of it. Granted, nobody right now is using Xbox or anybody's playing any kind of games, but even if we were using, you could tell I had plenty of bandwidth to use. When I was using my Stagecom router, I was kind of maxing out, and that's because of mainly because I were having my Wi-Fi devices were kind of causing issues with my network. Right now, I don't use that very, even though I have multiple devices. I have a total of 11 different clients coming across there. I may not be using all the basically all those devices on the wireless at the same time, but again, those are going to take a toll on my device. Depends on how much system resources. Again, this comes down to what kind of hardware I have. I have a UDM Pro. I prefer to use small business equipment just because I don't want to make sure I can handle multiple address assignments without a problem, because I want to make sure I have a client that can use what they call multi-channel MIMO, or basically multi-channel input-output, so that we can allow multiple devices to connect at the same time. There's nothing like getting frustrated that trying to have everything switch on and off. So it does make a big difference on what kind of equipment. And that's what would come down to the next topic. When you go and say I'm running slow my wireless, is that because of the fact that the ISP is having a problem, or is that because of the problem of where your house is located, how your house is laid out? It comes down to how many walls you have and where everything's located at. So it does make a difference. Now there's a couple different things. So let's say, example, we're having some internet problems. There are some utilities you can use, and we're just going to use some. We're going to go ahead and go through Linux, and we're going to actually go and show some there. Now you can do the same things with running most of these same commands. You have Windows. You can run the same commands by running Windows and Mac. Now on Windows, your site commands the trace route's going to be slightly different, and you're not going to have all these utilities. On a Mac, you're going to have the same utilities we're going to have here on the Linux. Now, let's go ahead and use the first one. Let's go ahead and check and see if I'm having a problem here, because we're talking about, or we're bringing this up before. We want to look at, hey, if we're having problems with my game, let's go ahead and look at what does my ping rate look like, because that says Xbox says if you have over 150 milliseconds, that can cause issues. So the thing we're going to do here is let's go ahead and we'll go ahead and run a ping. We're just going to run to Google right now. And you can tell I have a 16.8 to 20 millisecond there. I'm getting an average of 120 millisecond responses. That's going to vary by server, so that's going to be there here. So we're going to go ahead and run a trace route. The next step we're going to do here. So we're going to go ahead and this time here. And this is going to tell us if we have any kind of problem. So if we're going to have we're going to check maybe from where I'm located at, pair to where the actual basically a pair to where that server is located at. So you'll find your ISP's address. You'll find your local address, which this is my first hop is always going to be my router. My second hop is going to be my ISP. My third is going to be using your basically in the case I'm in the Midwest, so it's going to be in the Midwest there. And the main one we're going to actually be looking at is what's called the T-mode, because that's where right there. This is where the difference between where the actual Spectrum network in this kind of case, because that's whoever my provider is, goes out to whoever the third party provider is. So that's going out to Google. So if you're going to say, hey, if I am having a problem, if you see stars, it doesn't always mean that's a bad thing. That just means I have a firewall in the midst of it, because that way they can't be able to see it. So there's a lot of things. The other thing is let's say example, I couldn't ping a website here. Let's say I don't know a website that's not existing, so I can't show you an example of it. But let's go ahead and just say, hey, I want to ping www. Here. I don't think there's really a site that has this. It says, hey, I can't find this because they can't find a server or any kind of address about it. So what you'd want to do, if you want to have something like this here, to show you here, if you want to see what we're going to do here, see if the website here, we're going to have it use a site that's called Dig. So that gives us a couple different information. Let's go ahead and pull the Dig information Google here. It tells us a lot of information about this here. We can tell, hey, this is where this is going to tell us what the server address is, if they have one address or multiple addresses. In this kind of case, where we could do the same thing here with I want to go ahead and check maybe I have an error. Let's say I'm having problems with going to watch.spectrum .net. And it tells me, hey, look, this is an AWS server. Here's the main server comes through here. This tells us, it tells us a lot of information. It says, hey, we found this information based off of your responses here. So it kind of gives us an indication. So if I maybe had problems with it, or I want to see where I may be running into problems, I could go and say, hey, let's go ahead and ping the address that comes through for that DNS inquiry. So in this kind of case, we could ping just the AWS server, or we can also just do like we were doing here before on Google. We could just go and say, hey, there's a address we need to pull from here. We could just ping that address if it can find it, so we can actually see if they're here. So let's go ahead and we'll do another site here. Let's go ahead and dig Spectrum.net and see how Spectrum.net has two addresses here. We could go say, hey, we can see if Spectrum's up here. So let's go ahead and try to do that. So let's go ahead and ping this address. Put the wrong one here. And this is going to show us, hey, if the site's up or not, or see it here. And in theory, we take that same address, and maybe are we just having problems with maybe our DNS? So we can go up here and type in, hey, we have a connection up 52.20.172.25. And it says, hey, this is an unsecure page, so we're normally would say no, but we're going to say here, let's go ahead and open this in an unsecure incident. Are you sure? Yes. And it says 503 because they're going to say, hey, this is not a routable address because this is an HTTPS website, which is good. That's what we want to see. So those are things you can also see. If you have, for example, Google, if you want to be able to, we didn't know maybe Google's not coming up, but we pulled the dig record for Google last time to seen it. So in this kind of case, we use 172. So let's go ahead and pop this into our address bar here. So we're going to go ahead and say, hey, let's see if Google's up here. Says, are you sure you want to continue? Sure, we really don't want to do this normally, but this in case we'll do this time. And look, we're at Google right here. It takes us right here. It says, hey, we took this is what they call the DNS inquiry. So that's one of the things we need to be able to, then at that point, we want to say, hey, maybe if we can't get to this, let's go ahead and check our DNS server. So in my kind of case, go to wire connection. We're going to go to wire settings, and let's go ahead and, actually, easier way, we can actually look at the Windows, you would type in ipconfig/all, or in this kind of case, we can just go ahead and there's our ifconfig, but we can also check it by logging into our router, which is the easiest way to be able to check this here. So we're going to go ahead and do this. So in this kind of case, if we want to see what our DNS servers are here, and then we go here, and then we're going to go ahead and go to settings, and then we're going to go to internet, and we're going to WAN addresses, and we're going to go to the first one here, and if you haven't already overridden, we'd look right here, and that would tell you your DNS server. Currently, I'm using Cloudflare as my number 1, and I'm using OpenDNS as my number 2, but normally you would see your ISP's addresses there. The other way you can also look and see what, if you want to be able to check and see what you're going to be able to do here, is we can also go to your settings, go to your basically go to your connections, go to your little tab here, and where it says DNS right down here, you can actually see your DNS. And the same thing, go to your network adapter Windows. You just type in ncpa.cpl, take you right to your network connections. Double click on the adapter you're using, and you can also see that in Windows. That right now I am currently using Linux Fedora, so that's where I'm going to use it. But pretty much the same thing if you want to be able to pull it up. Other thing you might want to look at is if you want to, let's say example, maybe we don't know what address is, or we want to check maybe we found some invalid records here. So let's go ahead and check and see who actually owns that address here. So we're going to do an IP address lookup, and we can do it, or whose record. Let's go ahead and look up the person. So if we want to see, hey, let's go ahead and pull. So let's go ahead and pull one of our examples. You're going to pull up our command prompt again. we're going to go pull Google's again here. So let's go ahead and say, hey, this is one, let's say, example, we want to check and make sure this is who this is here. We saw this in our log here, 172.217.0.4. Go to go. And it says, hey, look, we have Google right here. It tells us address. It tells us it's owned by here. And we can actually look, if you really want to go any more, we can probably even look at if there was anybody abusing that. They probably have the abuse, so you can actually look up the record and see here. Let's do a geographical lookup. So this tells us approximately what part of the country they may be in. So that kind of gets them narrowed down of, hey, who maybe this could be. So we want to see here. It says, hey, look, this server's out of Chicago, Illinois. So we can go, hey, we know where we can kind of give us an indication of maybe where that device is, so we can be able to kind of look at it. So we know in Chicago, that would give us a good indication. So the other thing, we can also give an indication here. This kind of goes to our next thing here. Let's go ahead and go to look at our speed test here. So we're going to go ahead and here. Let's go ahead and make sure. We'll see if we can pick up, hopefully it picks up our Chicago server here. It does. So we're going to go ahead and run the speed test. And look, we're getting pretty good speeds off the Chicago server. Now, what we could do is, you want to get a little bit more information, we could also go to speedtest.net, and we can also change the server location here. So that way, maybe we have the server, we'll say example. So let's say we're in Columbus, Ohio. Maybe we're looking for Tampa. Maybe our server's in Tampa, Florida here. So let's go ahead and pick the one over here. Now we can take a look and see if we run. We can go and run a speed test to one of the connections to the middle of Tampa, Florida. Kind of see maybe it's that server causing some issues, or a server latency between each of the connections. So again, it depends on also what server you use, because it may depend on where you're pinging to, can make a huge difference. We'll use the example of a site usually pretty good, but it usually has problems here. So we're going to go ahead and run fast.com. It's doing fairly good, but it's not as good as some of the other ones here, because it depends on where that server is. It can make a big difference here. It's about 100 megs slower than really what my connection is. But again, this is things you can also see here. You can also show more information here. Tells you what your upload is, tells you your settings, and it tells you where that Netflix server, basically where your server's coming there. It tells you how, basically how it's doing its bandwidth. Tells 1 minute, tells you the maximum, tells there. And here, let's go ahead and save this settings here. Tells you your millisecond responses, because that does make a big difference on your upload and download. So it depends on how fast can that server pull here. It's telling us how much, if when it tests the file, how much connections down, what you're seeing here. Tells you latency between that server, because that does make a difference here. Tells you what server you're out of here. In this case, we're servers in Chicago, because that's where our level 3 is in here. And level 3, how it works is you always go from your ISP to a level 3 and a level 3 connect. Those are kind of interconnectors between each of the server providers. So in case of, for example, if I want to go from Spectrum over to AT&T, I'm going to have to go from Spectrum, connect over to a level 3, then connect to AT&T. So it's kind of like the interconnection between all the connections across the country. No matter how many hops you need to make, which is what we're running a trace route does, it tells us how long does it take to go from point A to the ending point. So it could be point A to point C, or point A to point Z. It depends on how far drops we go across, depending on there. It's kind of think about it as a GPS map of going from your friend's house, going to the store, going to the next one, kind of a list of kind of the drops it takes. Because it may be, actually probably a better example would be, it's kind of like driving from your friend's house, but you need to go, it's not like you're going to have a straight shot down Main Street. You may have to go to 3 different freeways to get there. And it's the same thing what this is doing. depends on how long it takes to get there. That's why it takes difference between sometimes on why it takes different times going to maybe like an Activision server compared to going to a something like going to like something like Facebook server, because it depends on where that server location is.